welcome back. In today's video, we will solve the LeetCode problem partition list. You are given a linked list and a value x. Your task is to rearrange the list so that all nodes with values less than x come before the nodes that greater or equal the value, while keeping their original order. Let's take an example. We are given this input, we have a linked list, and we have a value x. And our job is to split the list into two sections and then combine them while reversing the order. Now, we will use two separate lists to group the nodes. We should create one list with values that less than the value of x, and another list for nodes with values greater than or equal to x. Then we will combine these lists to get the final result. So now, let's create these lists. Now, we should iterate over this linked list. Let's start. Now, we have 1 less than x, less than 3. So we should add this one before in the first list, before the value of 3. So now we should add 1 in this list. Okay, 4 is greater than x, so we should add 4 in the second list. Now we have 3 equal or greater than x, so we should add 3 in the second list. Okay, we have 2 less than x, so let's add 2 in the first list. And now we have 5 greater than x, so let's add 5 in the right list. Okay, we have 2 less than x, so we should add 2 in the first list or in the left list. Okay, don't forget that in our list the 5, okay, let's take another color. Okay, 5 still point at 2 and 2 still point at null. Okay, now after we generate these two lists, we should combine these lists. So we should, okay, take another color. Okay, we should make 2 refers at the first element of the second one, and remove this pointer, make the latest one in the second list refer to null. So with that, we have new list, a new partitions list. And the time complexity for this solution is O of 1 because we iterate over each element once. And the space complexity is O of 1. So let's try code this. We should create our dummy list. Let's call it left list. And we have right list to store all the nodes with values greater or equal to x. And we should create variables to point to the trail of each list to combine them. Let's call it left trail, okay, equal left, and right trail equal right. And next, we will loop through each node in the original list. If the node's value less than x, we add it to the left list, and otherwise we add it to the right list. Now, let's create a while loop. While we have head, now let's ask if the current value, the head value, .val less than x. If it less than x, we should add it to the trail. To the left list by make the left trail dot next equal head, and the left trail should point to this head. So let's write it. Okay, and let's make this a trail. Okay, point to the next one, because the left trail, the first node in this list is dummy 1. It's have no value, it's a null value, so we should make it refer to the next one. Dot next. Okay, now if the value greater or equal to x, so should have else. Okay, now we should make the right trail dot next equal head. Okay, also the same thing, trail equal the right trail dot next, because the right trail is a dummy one. So after we check this, we should move the head to the next node in the original list. So let's add head equal head dot next. Okay. As we said before, now after we generate these two lists, we should combine these two lists. We should connect the left list to the right one by let's make the left trail point to the right list, and the right trail, the last one, the last node in the right list should refer or point to null. So let's write left trail, okay, left trail dot next equal to right dot next. Notice here, okay, the equal left trail dot next equal right dot next, not right, because as we said before, the right is a dummy node, has no value. Okay, and the right trail dot next should refer to null. None. Okay, after this, we should return the first node in our new generated list, which is the left dot next. Left dot next. As we said, because the left is a dummy node. Okay, let's try run. Okay, submit. Oh, great. So, guys, we have successfully partitioned this linked list, and as we said that this solution runs in O of n time complexity, because we only visit each node once. If you enjoyed this video, don't forget to like and subscribe, and don't forget to try this problem yourself, and goodbye.